Alright, we're studying exponential functions in calculus at the moment, and in this particular set we are looking at curve sketching. So how to use the first and second derivative to help us better perceive how exponential functions are going to look when they're multiplied with other functions, for example. So in the first case we're going to examine what happens when you take an x squared function, multiply it by the e to the negative x function, that's exponential decay. What happens when we multiply them together? What's the graph going to look like? And we can do some early analysis, but this video is going to focus specifically on the algebra calculus skills. So to find for curve sketching, we need to find maxima, minima, and inflection points. And in order to do so, I need to take the first derivative. So we need to remember to use the product rule. First times the derivative of the second, second times the derivative of the first. And that's what's done here. We consider these to be self-evident at this point, I hope. And then just cleaning it up, the negative times the x squared gives me negative x squared. And the 2x times e to the negative x looks nicer when it's written by like 2x times e to the negative x. At this stage, it's important to look at what's here. Here is an e to the negative x, and here is an e to the negative x. That's the nature of calculus with exponential functions. I'm going to take that and factor it out. It's going to give me this result. It turns out that this result is so much easier to work with, not only to find the second derivative, but also to find the maximum and minimum points. So I'm putting in when does the function equals 0, and I'm looking at the product of these two functions. This exponential decay function will never reach 0. So asking when will this equal 0, the answer is, well, this portion of the function will never equal 0. So the only time the whole function can equal 0 is when this little quadratic part equals 0. So all I have to do is take that part equal to 0 and factor out an x and find that x could be 0 or 2, and that's where the maxima or minima are going to occur. Now what you see up here, I'm actually evaluating the function at 0 and I'm evaluating the function at 2, and I can infer that the minimum occurs at 0, 0 because 0 is a smaller y value than this positive number. If you're not feeling good about that, you can go ahead and put 4 over e squared in the calculator and you'll find it's about just bigger than a half. So I know this has to be the maximum value, this has to be my minimum value. So I know where the maxima and minima are occurring, and I have an idea what the graph might look like as a result, but I need to use the second derivative now to help me find inflection points. So that's what's going to happen here. Use the final result of our first derivative right here, and as we can see, we're going to take the first times the derivative of the second times the derivative of the first, or however you want to look at it, and notice, for example, the negative e to the negative x, that's the derivative of e to the negative x, and the negative 2x plus 2, that's the derivative of negative x squared plus 2x. So continuing forward, we once again recognize both terms, e to the negative x, e to the negative x are contained in both. So when I take that out, I see the 2x minus 2 minus the x squared plus 2x. Here we have to make sure we understand this negative right here did not get factored out, so this negative has to stay and multiply by all this stuff. That's why I end up with this. Now to set the second derivative equal to 0, all I have to do is set the quadratic piece equal to 0. Same reasoning, this will never equal 0, this will in two places probably, and my job is to find it. So I have to solve x squared minus 4x plus 2. If you don't remember the quadratic formula, it's a good time to learn it. Here I'm using the quadratic formula QuickTime, and I simplify very quickly to get 2 plus or minus the square root of 2. If anybody needs help on how to get from here in the quadratic formula down to here, please see me, I'll be glad to help. So here's what we're going to do. We're going to take all that information, the minimum, the maximum, and the x values of the inflection points, and put it together on a graph. So there's the maximum, there's the minimum, and the inflection says go from your maximum 2 and go plus or minus the same amount. Square root of 2 is about 1.4. So in my graph, I am going to go from this maximum point right here. I'm going to go over 1.4 to the left, over 1.4 to the right, and that's where my inflection points are going to be. Now the exact location of those inflection points I don't know, but I'm making sure when I draw my graph I show a horizontal tangent, inflection, so the concavity goes from concave up to concave down, back to concave up again. So I'm making sure that all the details are in place. So we got concave up, concave down, concave up again. Notice it's concave down when we are between these inflection values. Anyway, just to have fun, I put the graph into Desmos, and then I copy-pasted the graph that I just drew freehand to see how close I was. And I was really happy to see that result. So that's the part about the game that can be fun, is if you analyze a function by hand and you end up with results that are consistent with a calculator or computer, something to be proud of. You have analysis. So have a great day.